In this video, you'll learn how to implement streaming responses from Claude models in Python, enhancing your machine learning applications with real-time data processing capabilities. Ever wondered how to make your AI applications more responsive and efficient? In today's fast-paced tech world, the ability to process data in real time is crucial. Welcome to our session on streaming Claude model responses in Python. We'll explore how Claude models, renowned for their advanced natural language processing capabilities, can be optimized through streaming. This technique not only enhances performance but is also pivotal in real-world applications where instant data processing is key. Stick around as we set the stage for an in-depth exploration of Python implementation in the next few minutes.
Before diving into code, it's essential to have our Python environment set up correctly. Start by ensuring you have the latest version of Python installed, ideally Python 3.7 or newer. We'll need packages like requests and WebSockets for handling HTTP requests and real-time data streams, respectively. Use pip to install these packages. Setting up a virtual environment can help manage dependencies efficiently, preventing conflicts between project libraries. Regularly updating your libraries is crucial to avoid security vulnerabilities and leverage the latest features. Let's configure our environment and prepare it for streaming Claude model responses. Why is streaming such a game changer in AI applications? Imagine reducing latency significantly, allowing your model to process inputs almost instantaneously. This not only boosts efficiency but also greatly enhances user experience by providing faster responses. Real-time data processing is indispensable in scenarios like live customer support or dynamic content generation. Streaming allows for scalable solutions, adapting to increasing data loads without compromising performance. By the end of this video, you'll see how streaming can transform your Claude model integrations, making them more agile and responsive.
Let's get our hands dirty with some code. We'll start by writing a basic Python script to handle streaming responses. Open your preferred editor and create a new Python file. First, we'll import necessary libraries like WebSockets and Asyncio. Set up an asynchronous function to manage WebSocket connections. This function will handle sending a request to the Claude model and receiving the streamed response. Ensure to handle opening and closing connections properly to avoid resource leaks. After writing our code, we'll test the setup by sending a sample request to verify the streaming process.
Errors are inevitable in any application, and streaming is no exception. Being prepared with robust error handling mechanisms is crucial. Start by identifying common errors like connection timeouts or data mismatches. Using Python's try-except blocks, we can catch and handle these exceptions gracefully. Implement logging to track errors and debug effectively. In case of dropped connections, a graceful reconnection strategy is essential to maintain stream continuity. By proactively managing these scenarios, we ensure our streaming setup is not only robust but also resilient under varying network conditions.
Optimizing data flow is key to unlocking the full potential of streaming. Start by minimizing data payloads and only essential information to reduce bandwidth usage. Compression techniques can further optimize data transmission, speeding up the process. Additionally, reduce processing overhead in your Python code by optimizing algorithms and data structures. These strategies not only enhance throughput but also ensure your application remains efficient under heavy load. By fine-tuning your data flow, you'll achieve a seamless streaming experience, crucial for real-time applications.
Integrating your Claude model streams with APIs can expand their functionality significantly. Begin by understanding the basics of API integration: how to connect, authenticate, and exchange data. Claude model offers specific API endpoints for streaming responses, so familiarize yourself with these. Ensuring secure connections through authentication tokens is vital to protect data integrity. We'll walk through sending and receiving API requests seamlessly. Finally, explore real-world examples of API integration, demonstrating the practical applications and benefits of combining Claude models with other systems.
Maintaining performance and scalability is essential for any successful streaming application. Start by optimizing resource usage. Ensure your system efficiently utilizes CPU, memory, and network resources. Implement scalable architectures that can adapt to increasing data loads without compromising performance. Monitoring system performance through logging and analytics will help identify bottlenecks and areas for improvement. Regularly updating and maintaining your codebase is crucial for security and performance optimization. Finally, consider employing load balancing techniques to distribute workloads evenly, ensuring consistent performance even under peak demand. As we wrap up, let's recap the key techniques we've covered for streaming Claude model responses in Python. Remember, practice and iteration are essential to mastering these skills. Don't hesitate to experiment and push the boundaries of what you've learned. Engage with the community, share your experiences, and utilize available resources for continuous improvement. Before you go, we'd love to hear your thoughts. Comment below on what you found most valuable and what you'd like to explore next. Don't forget to like, share, and subscribe for more insights into AI and machine learning.